Welcome back. In the previous episode, we established that a model needs a lot more than just raw coding ability to be a good agent. It needs reasoning, tool calling fidelity, and grounding. But today, we are going to look at the other half of the equation, the harness.
Exactly. If the LLM is the brain in a jar, the harness is the body, the hands, and the nervous system. And for a long time, the industry treated the harness as just a thin, invisible layer, a simple script that passes messages back and forth between the user and the API.
But that is completely false. The harness is actually an incredibly rich layer of software. In fact, if you take the exact same base model and you plug it into two completely different harnesses, you will get two wildly different results. The harness dictates the agent's behavior just as much as the model does.
This is a crucial concept to grasp. You might try an agentic tool and think, wow, this model is terrible at coding, when in reality, the model is fine. What you are actually experiencing is a poorly designed harness that is starving the model of context or trapping it in bad loops.
To prove just how thick and influential this layer is, we don't have to rely on anecdotes. We can actually look at the public evidence from standardized coding benchmarks.
Quick, honest note before we dive in. This is an education series, not advice of any kind. We are just two curious people trying to make AI make sense.
And AI moves fast, so everything here is how things work as of 2026, and it will keep changing. Treat it as a map, not gospel. The real learning happens when you go and try it yourself.
Let's look at SWE-bench, which is one of the most famous benchmarks for measuring how well AI can resolve real-world GitHub issues. If the harness was just a thin wrapper, then a specific model, say a top-tier Claude or GPT, should get the exact same score every time it takes the test.
But that is not what happens at all. On benchmarks like SWE-bench, the exact same model scores significantly differently under different scaffolds. We saw this clearly in public research from projects like SWE-agent and OpenHands.
Right. The OpenHands team and the researchers behind SWE-agent demonstrated that by changing the tools, the prompts, and the environment, while keeping the core LLM exactly the same, the success rate on resolving bugs jumps dramatically.
They proved that the environment shapes the intelligence. If the harness provides better search tools or formats the error messages more clearly, the model suddenly looks vastly smarter. It resolves issues it previously failed on.
It is undeniable public evidence. The harness is not a neutral messenger. It is an active participant in the reasoning loop. So, what exactly is inside this rich layer? Let's break down the major components that make up a modern harness, starting with the biggest lever of all.
The most influential piece of the harness is the system prompt. This is the hidden rulebook. Every single time the harness talks to the model, it secretly prepends a massive set of instructions before it even sends your request.
And these system prompts can be thousands of words long. They tell the model exactly who it is, how it should behave, and what it is forbidden from doing. A good harness has a meticulously engineered system prompt that acts as a behavioral guardrail.
For example, the system prompt might say, "You are an expert developer. Never delete code without making a backup. Always run tests after making a change. Format your tool calls using this exact JSON structure." This hidden text is arguably the biggest lever in the entire system.
If you take a brilliant model but give it a weak system prompt, it will act like a junior developer who doesn't know the company policies. It will guess, it will overwrite files, and it will break things. The system prompt forces the raw intelligence into a disciplined workflow.
And different harnesses use different system prompts. Some optimize for speed and brevity, while others optimize for extreme caution and deep reasoning. That alone accounts for a massive difference in how the exact same model feels to the user.
The next layer of the harness is how it handles tools, retrieval, and context management. We talked about tools before, but the design of those tools is entirely up to the harness. Does the agent have a blunt grep tool, or does it have a sophisticated language server that can instantly find all references to a function?
The quality of the tools dictates what the model can see. If the harness only provides basic text search, the model has to burn precious laps stumbling around the codebase. If the harness provides intelligent indexing and semantic search, the model finds the answer on the first lap.
Then there is context management and prompt caching. The harness is responsible for packing the context window efficiently. A rich harness knows exactly how to order the files, the recent terminal output, and the compacted summary so that the model doesn't get overwhelmed by noise.
And with prompt caching, a smart harness can save users a ton of money. It caches the massive system prompt and the codebase index so that subsequent laps are incredibly fast and cheap. The model doesn't do this natively. The harness has to orchestrate it.
So, if you're using an agent and it feels incredibly fast and always seems to know which file to look at, you are benefiting from a well-engineered retrieval and context layer in the harness.
Moving deeper, advanced harnesses don't just run one loop. They use subagents and parallelism. If you ask an agent to research 3 different API endpoints, a rich harness might spin up 3 separate background LLMs to read the docs simultaneously and then aggregate the results.
The base model has no concept of doing things in parallel. The harness builds that capability. Another massive feature is automatic verification. A great harness won't just accept the model's code and stop. It will automatically run the linter or the test suite in the background.
Yes, if the test fails, the harness intercepts the error, feeds it back to the model, and forces it to try again, all before you even see the output. It turns a one-shot guess into a rigorous verification loop.
Finally, there's permissions and sandboxing. A responsible harness runs the agent in a secure, isolated environment, like a Docker container. It ensures that the model cannot accidentally run a malicious bash command that deletes your personal files.
The model doesn't know what is safe or unsafe to execute on your machine. The sandboxing layer of the harness is what protects your operating system from a hallucinated command.
When you look at all these components, the system prompt, the tools, the context caching, the verification loops, you start to realize there is a distinct asymmetry between what the model does and what the harness does.
We like to say that the model sets the ceiling on reasoning, but the harness sets the floor on efficiency and defines the breadth of what is even possible. Let's unpack that.
A great harness cannot fix a weak reasoner. If the base LLM simply cannot understand a complex logic problem, no amount of prompt engineering or fancy tools will force it to solve it. The model's raw intelligence is the hard ceiling.
But conversely, a terrible harness can absolutely ruin a genius model. If the harness feeds the model garbage context, gives it broken tools, and fails to catch its syntax errors, the genius model will crash and burn. The harness dictates whether you actually reach that reasoning ceiling.
Furthermore, the harness expands the breadth of capabilities. The model cannot run tests, cache prompts, or spin up parallel subagents. The harness adds those superpowers, fundamentally transforming a text generator into a robust software engineer.
The best analogy for this relationship is the automotive industry. Think of the LLM as a high-performance engine. You can take the exact same turbocharged V8 engine and put it into 2 different cars.
If you drop that V8 engine into a rusty pickup truck with flat tires and a broken transmission, the car is going to drive terribly. It will have terrible handling, it will waste gas, and it might even crash. The engine is brilliant, but the vehicle around it is holding it back.
But if you take that exact same V8 engine and drop it into a state-of-the-art Formula One chassis with aerodynamic downforce, racing tires, and a flawless transmission, it will break track records. The engine hasn't changed at all. The car around it did.
The harness is the chassis, the transmission, and the tires. It decides exactly how much of that raw horsepower actually reaches the road. That is why 2 different AI coding tools using the exact same underlying LLM can feel like completely different products.
So, when you are evaluating AI agents, don't just ask, what model is it using? You have to ask, how good is the harness? The engine is important, but the car defines the ride.
Let's recap. The harness is not a thin wrapper. It is an incredibly rich layer of software. Public benchmarks like SWE-bench prove that changing the harness dramatically changes the success rate of the exact same model.
The harness controls the system prompt, tool design, context caching, subagents, verification loops, and sandboxing. While the model sets the ceiling on reasoning, the harness sets the floor on efficiency and determines what the agent can actually accomplish.
In our next episode, we are going to look at the broader landscape of AI coding tools, and we will share a critical lesson in grounding that every developer needs to know. See you then. And that is a wrap for today. If this made AI feel a little clearer, do us a favor and subscribe. It genuinely helps more curious people find the show.
We are learning and building with AI right alongside you, one episode at a time. So hit follow, and we will see you in the next one.